Assalamu alaikum guys. Today we are going to deliver our lecture on chemistry 1. We will start with chapter number 1 and here is the introduction. First of all, you should notice that why we are studying chemistry and what is the role of chemistry. Have you ever noticed that chemistry only plays role for the properties, composition and structure of matter? So it deals only about properties of matter. Just properties is an essential distinctive attribute or quality of a matter. You can say either it is flammability, toxicity, color, smell, taste, or functions. Next thing, chemistry has the role on composition. Composition is the ratio of atoms in a molecule, that how many atoms are in one molecule. So H2O contains atoms in the ratio of 2:1. Next is the structure. This is the main topic which we study whole our chapter in grade 12. The way atoms are arranged in a molecule is known as structure. So chemistry plays a main role in properties, composition and structure, and we study all from grade 9 to 12. Moving towards the next topic about significant figures. All reliable digits in a number which are known with certainty, the large digit remains uncertain by plus minus 1. So for this uncertainty, we prefer for the significant figures which are useful numbers. Either in addition, subtraction or multiplication divisions, significant figures are very important for all. Rules for determining significant figures is all non-zero digits are all significants, means 1 to 3. Zeros between non-zero digits are significant, just like 2001. So zeros are significant in it. Number less than 1 in a decimal format, just like 0.062, zeros are not significant. And number greater than 1 in a decimal format, just like 3.000, zeros are significant. Means 3.000 have 4 significant figures. Large zeros on a number greater than or equal to 1 are not significant, just like if a number is 1000 or 1 lakh, the zeros in after digit are all non-significant. Moving towards the next topic, rounding of data. To fix uncertainty in the last digit after a decimal is fixed by plus minus 1 or unchanged is regarded as round of data. So if a number is in decimal point, the numbers after decimal, there are some uncertainty in the decimal points. For there are some rules in rounding of data. Add 1 to the last digit if number to be dropped is greater than 5. Next, just drop the number if number to be dropped is less than 5. If number to be dropped is 5, then there are two possibilities for the case of even. If the number before 5 is even, just drop the number 5. For the case of odd, if the number before 5 is odd, add plus 1 to the odd number and just drop 5. These are some rules of surrounding of data. Now we will move towards the next topic. Use of exponents and logarithms. All numbers in the power are referred as exponents. Mostly we use base 10 for the exponent to be more convenient. Here we will use that log b is the base, a is the argument and is equal to x. X is the power, we can is the number of a power. So log 3x is equal to 5. Here's the example which we convert into exponential form as 3 power 5 is equal to x. It is used in basically for the calculations of logarithm by converting into exponential form. Moving towards the next topic, use of logarithms. There are some certain formulas for the logarithm. So just for multiplication, log ab is equal to log a plus log b, and in division, log a divided by b is equal to log a minus log b, and in power form, log a power n is converted into n log a. This is for the simplicity of solving logarithms. We use these formulas to simplify logarithm problems. Moving towards the next topic, error. The difference between actual and observed value is called an error. Errors we certainly depends on either instrument or human error. So there are two types of errors: systematic error, the defect in the analytical method, or by the improper functioning of instrument. If the instrument is not proper, then this error is known as systematic error that can be corrected. Random error, an error which cannot be removed but can be maintained. It is caused due to the uncertainty in every physical environment. So every physical environment or instrument has some uncertainties which cannot be removed but can be adjusted. Moving towards the next topic, here is the atomic mass. The mass of one of the element compared with the mass of one atom of carbon is 1/12 part of any atom is referred as atomic mass. This is very important that 1/12 part of any atom is referred as atomic mass. Next is the molecular mass. The sum of atomic masses of all elements present in a molecule. The actual formula is known referred as molecule. And when we find the mass, or we can say the sum of atomic masses of actual formula, so we refer as molecular mass. In formula mass, the sum of atomic masses of all elements in simplest or empirical formula of the substance. Just like if we take the simplest ratio of the molecular formula, that is called as empirical formula. If we take the sum of atomic masses of that simplest empirical formula, which will be referred as formula mass. Remember, molecular mass is different and formula mass is different. Moving towards the next topic, here is the empirical formula. Empirical formula, we can say that simplest ratio of the combining atoms in a compound. We find it to produce any compound in a large scale. Rules to find empirical formula: to detect the elements present in the compound, next to determine experimentally the masses of the elements, and to calculate the percentage of elements from their masses, to calculate the mole ratio of the elements, to obtain the simple ratio of atoms. These five are the requirements to find the empirical formula, and we will deal it with step by step in last topic. Moving towards the next topic, molecular formula. Molecular formula is the actual number of atoms of each element in one molecule. It is referred as the actual formula. We can find it molecular formula, but first finding empirical formula, then multiplying it with the constant n, we can find molecular formula. Quotient n is equal to molecular mass over formula mass. Molecular mass we will be given, and formula mass we can calculate by finding empirical formula. Here question we always get in numbers just like 1, 2, 3 etc. So here is an example of ethylene glycol. You can see it and practice it for the molecular formula. We will determine it in solving the question. Here is an example how to solve for empirical and molecular formula. Here is one example that ethylene glycol is used as an antifreeze. Combustion of 6.38 gram of ethylene glycol gives 9.06 gram of CO2 and 5.58 gram of H2O. Ethylene glycol contains carbon, nitrogen, oxygen, and its molecular mass is 62. Find empirical and molecular formula. First step is to determine element. Here three elements are used: carbon, hydrogen, and oxygen. Next step is to determine mass of each element. So for the mass of carbon, we can determine it mass of carbon from the CO2, because carbon is present in CO2, and we have given 9.06 gram of CO2 in question. We take atomic mass of carbon divided by molecular mass of CO2 and multiply it with the given mass 9.06, we will get 2.47 gram of carbon. Similarly, for hydrogen, atomic mass of hydrogen divided by molecular mass of H2O, and we will get 0.62 gram by multiplying it mass in 5.58 gram. Next is to find the percentage of each element. Percentage of carbon can be obtained by mass of carbon divided by actual mass of total element, just like we obtain mass divided by total mass, just like that. So mass of carbon we have determined in the previous slide, and here we are going towards the mass of carbon divided by total mass, and for hydrogen, mass of hydrogen divided by total mass. For oxygen, 100% minus 38.84% minus 9.72%, which will be equal to 51.44% for oxygen. Now we will move towards mole ratio of each element. Mole ratio is important. Its formula is percentage divided by atomic mass. So percentage of carbon we have found in the previous slide about carbon, hydrogen and oxygen. Now we will divide it with their atomic mass. We will get the mole ratio. So for mole ratio, carbon, hydrogen and oxygen 3.22 for carbon, hydrogen 9.72 and oxygen 3.22. For MCQ's point of view, you will get a percentage of each element and you will start from mole ratio to solve for the empirical formula or either for molecular formula. Next is our simplest ratio of each element. Simplest ratio will be equal to mole ratio of element divided by least mole ratio, which we have calculated in the previous slide. So mole simplest ratio of carbon is 1 and hydrogen is 3 and oxygen is 1. So here we'll get empirical formula which will be equal to CH3O. C is 1, H is 3 and oxygen O is 1. And in the similar pattern in MCQs, if your empirical formula is if you ask for empirical formula, you will simply find it through this formula. And for molecular formula, you will need quotient n is equal to molecular mass over formula mass. Molecular mass is given in the question and you will be given in the question as molecular mass for ethyl and glycol is given as 62 gram. We will divide it with formula mass. Formula mass means the simplest mass of your empirical formula, and in this similar way you can get 2 as quotient. After getting quotient, multiply it with empirical formula to get the molecular formula of ethylene glycol. So N is 2, multiply it with CH3O, you will get C2H6O2. Thank you for watching this video. Subscribe for more interesting videos.